Hello guys, how are you? Welcome to my YouTube channel. So I'm gonna taking you through the design of an expert system, right? I just have some steps and the architecture of our expert system, okay? I draw using the Wondershell eDraw, okay? So get to the business now. Uh, as you know, an expert system um, an expert system is a computer application which are developed to solve complex problems in a particular domain at, at the level of extraordinary human intelligence and expertise. Okay, so domains are very different and are much, maybe it's either in robotics, it's either in hospitals, in business, in academics, whatever expert systems takes place in. Okay, that's the domain. Okay, so we have some procedures or some steps we may follow to design such an expert system. Okay, so the expert system is the identification of the problem domain is the first step. Okay, what it says is that uh, choosing a problem, it says that the problem must be suitable for the expert system to solve it. Okay, so as you know, there is no way we can say this problem is attached to this expert system. Then you take another expert system. Let's say, for instance, we are taking a language translator to tell someone if she's sick from asthma or what. This will not be applicable. But we have to rely ourselves and be sure that our system, our expert system, will actually solve that certain problem. That's only the identification of the problem. Then finding the expert in the task domain for the expert project. What are we saying here? We're saying that we need to look for the available cooperative experts who can contribute without feeling that the system might make them feel redundant. And also we may need management and potential users with the positive attitude to the project we are developing, right? We are designing. Again, as you know, if you are to develop something, you need to be aware of the cost effective, meaning that our business is to be something that is most effective and uh, efficient, at the same time saving resources. So I just saying it is to bring more benefits to the company with the minimum cost that will be involved. Okay, so on the second step we have knowledge engineering right here. On knowledge engineering, what are we saying? uh, we need to identify the expert system technology, the knowledge engineer to look for the knowledge and became familiar with the area reading by reading texts or talking to the experts. So we need to look for those guys who are specifically intelligent or who is the expertise to that certain uh, problem we want to solve on. So we ask some questions, and those questions we'll be drafting them down so that our system will store those expertise at a large base as compared to humans. But remember, the goal right now is just to reduce and to increase the efficiency and the storage capabilities of the system as compared to people. People sometimes forgot as much, but machines are more precisely and they can store more data that it will always refer to. Okay, so we need to look for those guys. We may ask our questions, and those guys must be specifically knowledgeable about our problem domain. Okay, then We have to know and establish the degree of integration with other systems and databases. Okay, then we need it's just clear. You just need to establish the degree of integration of our systems with other databases in our working environment. Again, after that, we need to realize how the concept can represent the domain knowledge best. Okay, so going to the third step, which is to develop the prototype. This one is just similar as the fourth one, which is the expert system architect. But okay, let me touch on developing the prototype. Right, you just need to acquire the domain knowledge from the expert. You know, as I said earlier, that you need to identify the expert system technology. That's when we acquire domain knowledge from the expert. Then we represent it in the form of if-then rules. So if-then rules or else rules are then captured and stored into our database. Organized, so yes, into our knowledge base, or into our database, which is the knowledge base. Okay, so on the fourth step, which is the expert system architecture, right here is just here, yeah, that's our expert system architecture. So as you can see, it is the user interface, explanation facilities, inference engine, base facts, the knowledge base, and knowledge base editor. What are we saying? Those two arrows are just indicating that there is an interaction, right? The user feeds his what can I say, questions, or whatever questions she might be willing to ask to the user interface, right? And then the user interface will always displays back the output, either in form of images, visualization, or audios, or text, something like that. Okay, so the user interface will interact. That is when the user will interact with the system, right? Then go to the explanation facility. Let's say, for example, our user um, maybe it's just in a patient in a clinic. Okay, remember, take note of this. User might be an expert on a knowledge engineer or a non-expert. Okay, so if they ask the question, you need to see it back. So the user asks it through the user interface, and then the explanation facilities will send the request to the inference engine. Then the inference engine, what's its purpose right here? Then the inference engine, uh, it will reason with both the expert knowledge in the knowledge base and the data specific to the particular problem. Let's take this for instance. The user is um, having a constant headache. Okay, so if I ask what's the problem, right, the inference engine will ask the knowledge base, right? This inference engine, this is an interaction there, right here. So this inference engine will ask the knowledge base. Since the knowledge base have is the data storage now, if I can define the knowledge base, it's just with the knowledge, I mean the domain knowledge for problems are being stored. Okay, so it may be stored in our right here. This should be a database, not just a base, but this should be a database right here. This is our database. Okay, so this database stores our information, which we may refer to as our facts, right? So these facts, right, are the ones which may ensure that if the user is being having even eye problems, that means that headache is just in, I mean, a dangerous, I mean, an extraordinary headache she has been suffering from. So we may ask you, have you been drinking some waters? If say no, we have some other information which are stored right here. Because right here we store some information which might be in the case of if, uh, then, right, or else, right. So if the system will act like if you are suffering from this, then this. You see, if you are suffering from this, then you then conclude the results. But what it does, it sends back what is think right to be the truth or the actual answer. It sends back to the inference engine. Then the inference engine will send it back to the explanation modules. What happens here is that this whole component right here up to here, we can call it an expert system shell, because that's where the common knowledge base applications and questions are being performed, right? So the inference engine will send back the reasons or the results to the explanation modules. Then what about the explanation modules? What it does is that the explanation modules will allows the program to explain its reasoning to the user, isn't how the expert system reached to a particular conclusion, so that the user will actually understand, will eventually understand what exactly caused the reason to do that. Okay, so another here we may see this component might be kind of left it but it's only that knowledge base editor is there to allow the expertise or the knowledge engineer to easily update and check the knowledge base. Maybe it might be having insufficient knowledge, so the expert or engineer or knowledge engineer will always update through using the knowledge base editor right here. So I think that's all about our expert system, guys. um, Expert system development procedures, right? After that, if they any solve the problem is now clear. So I think we may look ahead on what I can say. We have what we call a back chain, right? Right here. No, sorry. Right here, we have a back chaining. Then we have the forward chain. So what happens here? Sorry guys, please forgive me for the wrong error. Okay, the chain right here. So these are two different methods that are being applied by the explanation modules to reflect back the reasons to the user interface, right? We have back chaining and we have forward chaining. We'll explain this in the next video. Thank you guys. Please share, leave your comment. Please subscribe and share the video to those who are interested in watching it. Thank you guys. Goodbye. See you later.